All right. So this problem has sort of hidden probabilities and hidden dependent events in it. So if you've read through this problem, it's a little bit confusing because it says the probability that Millie finishes the race is 60%, but then it goes on to say there's an 80% chance that she finishes if Rory finishes. So there's our dependent event. And so with your tree diagram here, what we're thinking of is not Rory and Millie, but instead Rory, and either he finishes or he doesn't finish, and then Millie, and either she finishes or she doesn't finish, and she finishes or she doesn't finish. So the probability that he finishes 55%, that means the probability that he doesn't finish is 45%. If he finishes, she has an 80% chance of finishing. So down here, this is 80% and 20%, but if he doesn't finish, she still has her 60% chance of winning, which would then be a 40% chance, finishing. 40% chance of not finishing. So the probability they both finish, probability of finish is 0.55 times 0.8. Let's see what that is. So main menu here, quit. Okay, we've got 0.55 times 0.8, 0.44. All right, probability that Rory finishes, so I'm going to do that, Rory finishes given that Millie finishes. So Millie finishing, what we're given are these two outcomes, so following this path, The only path where Rory finishes is this one, so that's my numerator. So we've already done this from above, that's 0.44. And now we have to divide by our two possible outcomes, which is the 0.44 plus 0.45 times 0.6. Oh, it does that bit. I hate it when I do that. All right, let's move this down. 0.45 times 0.6. All right, so let's figure out what that is. So we're going to divide that by 0.44 plus 0.45 times 0.6. All right, let's see if that turns into a fraction. I don't know if it will or not. All right, it does. So we can either leave it exact, which is our 44 out of 71, or we can approximate this to 0.620 to 3 significant figures. All right, so there we go.